Afternoon, everyone. We are here to talk about incident handling and post-incident analysis. We have two rough goals for this event, or for this talk. One of them is that thinking about you as customers of AWS, you may very occasionally be involved in an incident on the AWS side. And so you may be using the AWS Health Dashboard, you may be working with AWS support, and we want to give you a little bit extra context on what's happening on our side of the fence during those. The other is that, as you guys are probably owning services for your customers as well, you probably run your own incidents. Hands up, how many people here have run an incident or been involved in an incident? Okay, so that's pretty common. So hopefully by giving you a little bit of extra insight in what we do, you might pick up some stuff that you could use within your business.
And so here with me today is Gavin. Gavin has been at AWS for about 13 years, working as a senior principal engineer in teams spanning from load balancing to DNS and most recently application recovery controller. More importantly, Gavin is an AWS core leader that is our version of an incident commander, if you want. And we are going to discuss that later.
And Giorgio he is a principal within the AWS support organization. So our two teams kind of work together. During an incident, the group that I work with are on the call trying to mitigate the issue. Giorgio's team, meanwhile, are working with us to understand what's going on, communicating with customers, and making sure that customers get back to normal as quickly as possible.
And let's take a look at the agenda for today. So we need to start with a bit of a confession. We wrote the abstract 6 months ago, and while we started working on the actual slides, we realized that it's really hard to talk about what happens after an event without talking about how we manage events. So we are going to start by discussing what happens from once an event triggers to the resolution. And after that, we'll cover the post-mortem, so the retrospective phase, all the way to the definition and implementation of the action items. And in the third part, we are going to talk about how a post-mortem done by a team for an event that impacted them can be scaled across the organization so that it becomes a learning opportunity for everyone and not just for a small part of the company.
Okay, so if we get started, the first phase, so to speak, is the event itself. So the first thing we need to do is to detect, engage everybody, and work to mitigate the event. So not unlike, I imagine, how you guys work, our service teams all have metrics and alarms and are monitoring their services. And I'm sure you're no different with that. They will also very commonly have what we call canaries or synthetic monitoring. So we don't just trust our own metrics generated by the application. We have canaries impersonating customers all the time and making sure that the customer experience is right. One of the things that's a little bit different that may or may not be something you guys would be used to are what we call aggregate alarms. So if you imagine that obviously there are several hundred services in a region within AWS, even just facing customers, and they will all depend on one common network. They will all depend on one common DNS infrastructure, authorization and authentication, things like that. So there are certain times when an issue will impact on multiple services at the same time. And what we don't want is for 20 teams to simultaneously get an alarm. They're all related and they all independently try to investigate them because that's going to be a big waste of people's time. So what we have is this aggregate alarming detection system that we run in incident response in order that we can bring everyone together into one call and diagnose the problem together in a coordinated way.
And in addition to this, we have a type of metric that is indirect, if you want, and we call them customer-driven metrics. One example of those is traffic trends. So instead of looking for error conditions or for failures, we just check that that given service is receiving the amount of traffic we expect at that time of the day and that day of the week. The second one, even more indirect, if you want, is we track customer contacts to support. So when customers suddenly start reaching out about a potential problem on a service, that might be a really good indication that we had better go look at that service and check that it's working as intended.
So Amazon legend has it that an engineer back in about 2008, 2009 got frustrated on a Friday when he was visiting Seattle. He was from Dublin. He was visiting and he had a weekend to himself and he decided, I want a dashboard for all of AWS. And AWS in 2009 was a lot smaller than it is now, but he started off and built it in the weekend in his hotel room. And we've been maintaining it and developing it ever since. But it was kind of the nucleus of us having visibility across all of AWS. And so what you're seeing here, admittedly somewhat zoomed out and slightly blurred, is our top-level dashboard across AWS, where we keep like 3 to 5 key metrics for every service. And the idea here is that we're looking for, if there's one service with a problem, that service will probably deal with it, that's fine. But if there are multiple services, then we need to jump into action and run a call that coordinates across everybody. So again, we will have single service issues from time to time. Broadly speaking, those teams will just handle that themselves. They might need to engage us from time to time, but that's fine. And they may need another team involved. But the things that we're really focused on as incident response are the multi-service issues. And so we're using that dashboard and a set of automation that runs alongside it to see that. When an event kicks off, we usually detect within a couple of minutes of the event, and we will automatically engage the incident response primary, AWS support, his team. We will bring in usually most if not all of the impacted services. We may have the call leader, depends on how severe it looks. And we also usually page a set of usual suspects who are kind of like bottom turtle service owners, so they will tend to be there. And so what we're aiming to do here is, on the service side, really, we're trying to drive our time to recovery as low as possible, to end this event as quickly as possible by bringing people together and coordinating.
And on the AWS support side, we start a similar call and engagement. This one being focused on communicating to customers and providing guidance for a solution. It's staffed by senior members of the support organization and service leadership. And it's got essentially one goal, helping customers recovering faster. There are cases where customer action can get them out of the woods much earlier than we recover. And we want to help them with precise point-in-time guidance that is relevant to what they are doing and to the event that is going on.
So a typical quote that you will hear from AWS service leaders and call leaders is, investigate in parallel, not in series. If we've got 20 people on a call and somebody says, I think it's X, everybody will herd over to X. We have to be disciplined and say, no, guys, everyone check your own service first, and we will work on lots of hypotheses in parallel. Make sure you're good, and we'll figure it out. So the tech call, which the call leader and incident response run, like I say, is very focused on mitigation. And in particular, it is focused on mitigation first and root cause later. We will have a call leader if we need one. There's a fair bit of etiquette goes on these calls, and people kind of have to learn when they come to the company. One of the classic things is mute yourself when you're on a call. Turns out if you engage 100 people into a call, there is a very high probability that one of them will forget to mute themselves and have a conversation with their daughter or their wife, or grind coffee beans, or board a helicopter. You would be surprised the amount of noise that comes through. More recently, we now have video conferencing systems where we can see who's talking and we can mute them, and that has just changed our lives so well. From time to time, we will have the need for one team to go away with full bandwidth to talk to each other, to work on something complicated well. So we will have a couple of separate calls from time to time, and maybe the call leader will jump back and forth between those. We also have a tech ticket, as we call it, which is in our ticket system, basically a journal of what's happening throughout the event. And that is a really important sort of immutable record of what's happening throughout. And so you will hear very frequently on these calls, can you put that observation on the ticket, please? Because somebody has said something really insightful on the call, and we're about to lose that piece of information and that context because we haven't written it down. So these are snapshots from the tickets. This is a person posting an exception that they saw, or a cat. This is another cat noting that they started a rollback at this particular time. We have it timestamped, and we can all follow along and see the rollback happening. There's a link there. This is somebody posting a graph, a snapshot of a graph that will be there forevermore in this ticket. And we will now know that this is the graph they were looking at and we were looking at. Here's another one with somebody hypothesizing about what's going on. And so what we're doing here is sort of seeding our empathy for later. This is really important in the post-incident analysis, that you have a really good record of what we were thinking at the time.
And let's take a quick look at the AWS support call. So it's run by a team that is called AWS Event Management and Engineering after a recent reorganization. They own everything top to bottom related to running events and communicating to customers. They are the team that owns the status dashboard and all of the AWS health and related tooling. The primary thing we do in this call is we keep an eye on case trends. Case trends is a really simple metric. We count how many cases come in by service, and just to make sure that the tech call is looking at the right things. And we read impact reports from customers, once again, as a way to close the loop and validate that what we are investigating internally is exactly what customers are looking at as well. Another important duty of this call is external communications. This is the place where every communication you have ever seen about our events is drafted, defined. We decide what to communicate and when, and we ship back and forth the content before it goes out. As mentioned at the beginning, we work on recovery guidance. As what we have found out is that customers really value guidance that we can provide during an event. Sometimes it might be really easy, like stop the instances that are almost broken and replace them. Sometimes it's more complex about shifting away from IZs, but customers really want to listen from us and wait for our suggestions. We also tend to provide generic best practices, again, about excluding failing resources, shifting away, or running all of the mitigation actions that we are going to discuss later for our own services. And the last thing we do is, obviously, we try to work at scale. We try to work on items that have large-scale impact and work for the majority of customers, but there are edge cases, so customers that have specific situations or conditions. And this is the place where we make sure that they are paired to engineers that can help them, and we keep an eye on all of the exceptions that are going on. This call is obviously in constant loop with the tech call. We will have people jumping back and forth, people being in bot calls at the same time. I don't know how they do it. And one thing I want to show you is Command Center. So Command Center is the third iteration of our all-in-one support tooling. What we see here is a module where we track events. So you can see the content is, we have metadata on the side, so what the event is about, impacted services and regions, start time. We have the case metrics that I mentioned earlier. So we track not only support cases, we also track what's happening on social media. So are we being mentioned? Are customers reaching out through those channels? And what you see on the right side of the screen is we try to give an overview to support engineers that are joining or that are being engaged, so that in 30 seconds they know what's going on and where to go look for information. A pointer to this specific notice will show up next to the support case management panel that our support engineers see, so that they can support you all, our customers, in the most effective way possible. Let's dive a bit deeper into event communication. So we have found out over time that communicating during events is a matter of balance, really. There are three forces that are relevant, and the first one is accuracy. So we want to communicate only what's relevant. We know that customers are going to take our notifications, engage their teams, and start working on an event. So we want to make sure that when we communicate is because customers, you all need to really take action. And we want to communicate right. So we want to make sure that if we say that there is an ongoing problem on a service, then it's really ongoing, or that we tag the right services, for example. A second one is depth. We hear from customers that providing a good amount of detail is critical so that they can take their own decisions or they can develop their own understanding of the event. The third one being quite obvious, speed. We want to get information out quite fast. It's important that whatever we know goes out to all customers as soon as possible, once again, to improve the engagement and to avoid investigating the same thing on both sides. We tend to go for the first and the third one. So as soon as we are sure that there is an event ongoing, we'll try to ship out a notification. Now, one thing that we have done over time, and that is an interesting technological approach to accuracy, is we moved from posting everything on the public status dashboard to using more and more personalized dashboard. If you've heard about it, it's essentially an account-specific view of health events. And that helps us only targeting customers that, for example, are running on an impacted cell of a service, and making sure that if customers get that notification, it's because they really need to look at it. And one thing we are currently working on, it's going to be interesting in the future, is we are going to give an option for customers to know as soon as we start investigating something. So imagine it as a really simple notification that tells you that we are investigating a possible event on a service in a specific region. Once again, this is going to be possibly noisy, will require some filtering, but we want to give customers options to look at this signal as part of their own monitoring. Communication is obviously not just a single stream. We need to make sure we provide the right messaging to the right audience. So internally, we have two types of audiences. One is the strongly technical one that is familiar with internal service names, terminology, internal components. And to this audience, we provide just raw updates. It can be a distilled version of the tech ticket or even the tech ticket itself. We don't do any filtering, and this is really fast. And then we work on regular bulletins for field teams, so teams supporting customers like you, so that at a regular pace they get information, summarized and cleaned up information on what's going on in a way that if an account manager or solution architect gets called in by their customer, they can respond and provide useful information. TAMs are the main technical account managers. My org is the main user of this type of information. Externally, we communicate not only the status of our services, but we try to provide recommendations on how to react and regular updates on what's going on, what our plans are, and what's the root cause we are looking at.
So back on the tech call, we're meanwhile working on mitigation. And one of the things that you will hear very often is, okay, you made a change, have you rolled that back yet? And like I said before, engineers are super fascinated about understanding all of the details of this event and really getting into the root cause, and they will spend a long time if you don't rein them in doing that. And it's cool, don't get me wrong, like I'm an engineer, I like doing it too, but our priority on the call is mitigation. And so we have a set of things that we will go through for this, tricks that we will have prepared. So one of them is shifting away from the failure. If you have a fleet of 10 hosts and you have a problem and one of the hosts has wonky metrics, take that host out immediately. Don't hesitate, let's just take that host out. We know we can afford to lose a host. If we have wonky metrics and we see this one AZ looks a bit strange, we will pretty quickly go, okay, let's shift everyone out of that zone and just see if that solves the problem. The second change that we make is we will roll back all the changes that we know are happening. So everybody who's making changes across Amazon, like network engineers, deployments, things like that, they all are expected to have the ability to roll back immediately. All of the change management tools, we will have rollback plans in there. And they are expected to roll back immediately, even if we don't know yet if they're the problem. So everybody roll back, and the chances are that one of those rollbacks is going to solve the problem for us. The third thing, particularly when we get to the point where we have narrowed down one service, is bouncing that service, even though you don't exactly know why yet. Maybe you log into one host in the fleet, you restart it, see if it looks better, and yeah, okay, it does. Now restart the fleet in the same way is a very effective way a lot of the time, even though we don't yet know the root cause, to be able to end this event as quickly as possible and get back to normal. Curiously, scaling up proactively is often very helpful. You will build up backlogs, there will be increased load probably around the event, and it is often very helpful to shorten mitigation time to just go, you know what, let's scale up a little bit now, assuming that's something we're prepared and safe to do, which it typically is. The last thing that we will do if we need to is actually make changes on the service. This is the sort of higher risk thing of actually making code changes in production, so we don't like doing this if we can avoid it, but we will if it comes to it. And so we mitigate the issue, blood pressure starts to return to normal, adrenaline starts to ease out, But we really do have to stay focused now. The question now is, are we at risk of this happening again? And so the first thing we will do is work with Giorgio's team to understand, like, do customers agree with us that we've mitigated it? Our metrics say it's good, but is it definitely good? We will work to understand, obviously, the root cause at this point and assess our risk of recurrence. So we will look to do things like stop all the deployment pipelines that are anyway relevant, particularly if it's one deployment. We will stop that pipeline, make sure this code is not going out anywhere else. We will halt change management very frequently, even before we've mitigated the issue, just to make sure that we're not making anything worse. Look around for other systems that might be affected by the same thing. The most common one in our case is this code going to other regions by any chance, or about to? So we make sure that's not happening. And so we're coming to the end of the call. Before wrapping up, typically we will talk about like a few short-term fixes just to give ourselves safety and stability. Like a common thing we would do is add an extra couple of alarms on metrics we've discovered during the call, just to make sure that if something does happen again, we will spot it quick. We will assign COEs, which are our root cause analysis type document. We'll talk a little more about that later. We will look for any data or logs to preserve, like if we've been doing heap dumps during the investigation, or if there are core files somewhere. Let's make sure that all of those artifacts that we can store are stored, because they're going to be really important later for our root cause analysis. Look for additional follow-up actions, agree on our next steps, and then wind the call down, let everyone go.
Okay, so at this stage, we are out of the emergency. The event is resolved, the customers have confirmed mitigation, and things are back to normal. And this is where we start reflecting on what happened and planning for the future. So reviews, postmortems, COE as we call them. There are a few principles we try to maintain while working on them. The first one is we try to apply empathy while working on COEs. Now, empathy means two things. One is create a safe space for the team that has been impacted. Make sure that they feel safe sharing about their failure and sharing details about their experience. They are not there to be blamed, they are there for helping everyone else learn and for learn themselves. And the second side of empathy is to run an effective postmortem, you have to really immerse yourself into the knowledge that they had during the event. You want to know what was going on at the event time and why some decisions were taken. Even at design time, you want to learn why that system was designed the way it was designed, so that any implementation, any change that you do will go as deep as possible in resolving the root cause. And the second one is we tend to talk about the post-mortem document. In reality, what we do in AWS is we make sure that they are a distributed effort. So if during the event we notice teams that we think have opportunities for improvement or to do something differently, we will assign COEs to them. So it's not unusual for a single event in Amazon or AWS to end up with up to 10 or 15 COEs. Teams can opt out. Getting assigned a COE means that they are requested to consider the option of doing a postmortem. And if they have really good reasons not to, they can just discard it. Now, why we do them? So first, as authors, the COEs are generally written by the part of the team that was as close as possible to the component that failed. And it's an opportunity to learn about the system. Maybe the system has been around for a while, and to make sure that the part of the team that is closest to it has got a full and deep understanding of how that service or subsystem works. As a team, it's an opportunity to learn and being curious. So you are going to have a spectrum of tenure in the team. There are going to be new members. And collaborating with the COE makes sure that helps making sure that they learn how the service works and why it works and it's designed in a certain way. As an organization, obviously, as a group of teams, it's important because they help sharing learnings. They are in written forms, easy to share and circulate. And the last thing often overlooked is whether you are offering a service to the public or you are a dependency of some internal teams, the post-mortem is your opportunity to earn their trust back. You want your internal or external customers to trust you and to trust that you have really understood what happened, that you have the actual root cause, and that you are implementing strong actions to prevent recurrence. Now, how is a COE structured? Well, they start with an impact summary. Our impact summary is a mix of internal and external point of view. So we want to summarize what the team knows about the service and the event, and what the customers of this team saw and what was their experience during it. We obviously have root cause. Once again, root cause, we tend to go with a singular. In reality, what we find out is that every event is a combination of multiple root causes and the 5 whys. We are going to talk about the 5 whys in a second. We had a somewhat random set of observations and learnings. So during the event, we might have discovered some behaviors that were not strictly related to the failure, but things we were not aware of, or things we have learned, gaps we have seen. We tend to annotate them in the COE as well, even if not directly related, strictly related to the resolution. And then obviously action items. We are going to talk about action items quite in depth, but overall, it's the list of actions that you are going to take to make sure that the same triggers will not lead to the same event or to the same failure condition. Just to take a look at a couple of sections we tend to spend a good amount of time on. The first one being detection. We want to be really self-critical and try to understand if we are happy with our detection time. So question number 1 is, did we detect the event fast enough? Did we detect that the system was not performing as intended in a good enough amount of time? And if the answer is not, obviously there is a deep dive by itself into understanding why and what we can do about it. Second one, we look at how we performed during the event. So we want to make sure that even during the event, we had the right observability to help us understanding how our actions were affecting the systems and helping with resolution. And the third one is about zooming out a bit. So not just looking at this very specific failure condition, but are we confident that if something similar happens with similar symptoms, are we going to be able to detect it? The second area where we invest a good amount of time is dependencies. So internal or external interdependencies between systems are really common. And if an event was caused by a dependency of the service we are running and not by our own service, we tend to ask, first, did we use the dependency as intended? So dependencies and systems are designed with some performance, with sort of a performance promise, both in terms of latency or availability. We want to make sure that we had the right expectations from it. And then, obviously, we validated the dependency performed as intended. So did this dependency maintain their promise that they made to us, and based on which we decide to use it? And the third one, we look into whether we should have expected the failure mode. So dependencies with 100% availability are quite rare. Each dependency or service is going to have a specific set of failure modes. We want to make sure we cover all of them and either deal with or understand how our service is going to behave when one of those failure modes shows up.
So this is a point in this talk where I like to get a little bit on a soapbox, so you'll have to let me apologize in advance. How many of you are familiar with the 5 whys mechanism? Okay. How many of you actively use it? How many of you dislike it? Okay. I have mixed feelings about it. It's a really short and pithy thing that you can say and everyone knows what you mean, so it's a really handy little phrase and a kind of terminology. But if you read it too literally, it doesn't really work out very well in my experience. So the first thing is, you probably shouldn't stop at 5 whys most of the time. And by the sounds of it, with the number of hands that went up, that may be familiar knowledge for you guys. Also, when we're doing this, the whys should not be a linear analysis. It is not a linked list. It is a tree. And so to give you a little bit of an example of this, we'll go through a slightly made up, but nevertheless perhaps something like it existed at some point. Why were API calls failing? One host in the fleet was returning 500 errors. Okay. Why did the host return 500 errors? The host could not write to its storage volume. Why could it not write to its storage volume? Problem with EBS. Why was there an issue with EBS? And okay, we have done 5 whys. We probably haven't got very good outcomes from this, though. The action items are we're not really winning at this game yet. So this isn't perhaps the best way you could do this, but a better approach. I'm adding a little bit more detail into the first question for a start. Nice and specific. Why were 3% of API calls failing for 45 minutes? And that's very deliberately to prompt ourselves to think a little bit harder. One host in the fleet of 100 was returning 500 errors. Okay, interesting. Why did the host return 500 errors? Okay, we're down the branch that we explored before. It's going to be a volume problem, fine. But there's a second branch that we should be asking. Why did our health checks not remove the failed host from service? Well, it turns out a misconfiguration in our health checking logic used a TCP health check when we needed something a little deeper. Why was the health check misconfigured? Well, we have these service templates and it's wrong in the template. So this is getting stamped out across all of these services. So this is a finding that is really powerful now. Let's keep going. Why did the problem persist for 45 minutes? The operator was not engaged for the first 30 minutes, so they couldn't do anything about it. Why were they not engaged? Because our alarming is set to 5% failure rate, which is not in line with our SLOs. So again, we have a new action item to do. Why did a failure of 1% of capacity cause a 3% API failure rate? That's kind of odd. Well, the load balancer is configured to use the least cons load balancing algorithm. I don't know how many people are familiar with that. And it turns out that when hosts fail, they often answer faster than when they are succeeding. And least cons will tend to go, okay, more work for you, failing host then. And so, yeah, it's a disproportionately large failure rate. And why was the load balancer configured to use least cons? Well, actually, this was a design decision. We thought about this at the time. There were reasons. And this is part of the story of the empathy. Maybe we may decide to change that now, but at the time, we want to understand why we made that design decision.
At this point, we are ready for the second act of our external event communication, the root cause analysis. RCA, RFO, we call them AWS event analysis, if you've ever seen one of them. So a few principles based on which we write them. The first one is we really care about the customer point of view while preparing an RCA. We want to make sure that it starts by spelling out quite clearly the customer experience. So starting from what the customer saw during the event, how their services were impacted, how our performance was affected. It's once again a matter of quality versus speed. It takes time to get all of the necessary details, and delivering a perfect RCA might take a couple of months. We want to strike the right balance, and we tend to take a few days to deliver one, and our threshold is we are going to ship it once we know deep enough what happened, once we have a full understanding of our actions, and we have agreed on high-level action items with deadlines. We make an active effort of removing unnecessary complexity. So as you can probably imagine, AWS is an extremely deep layered group of dependencies. But we don't want to just throw this complexity at customers. We try to abstract where possible without impacting the storyline, without impacting the customer needs for understanding what happened. But just removing detail, removing technical terms, and simplifying as much as possible, or reconnecting to concepts customers are aware of. So, for example, since we started talking externally about cells, the mechanism we use for segregating failures in our services, we started reusing that terminology in RCAs, just because at that point it became common knowledge across customers. And once again, we are really aware while writing an RCA that is not only our opportunity to satisfy curiosity or to explain what happened during that event, but it's also our one opportunity to earn the customer's trust back. We want to convince our customers that we fully understand what happened, that we have been introspective to an appropriate degree into how we reacted during the event. And we want to give confidence outside that we have the right action items to prevent any sort of recurrence to the same event or similar ones. So after we got this document out, it becomes all about planning for the action items we committed on. Broadly speaking, we have 3 categories of action items. The first one is short-term ones. So they tend to be delivered in hours, and we run 24/7 to deliver them. Those were the action items that Gavin was talking about in terms of we don't consider the event closed until they are delivered. They are generally focused on preventing the immediate recurrence of an event, and they might significantly increase the operational load. So sometimes we make alarms more sensitive. Some other times we change the run books, and they are good enough for short term, but we need something better. The intermediate category is mid-term action items. They tend to be delivered in days, weeks, months, sometimes, rarely. And they are just more stable solutions, more often fully automated solutions that ensure that if the same triggers verify, then the event will not just reoccur the way it happened the first time. And third category, we have the long-term action items, the ones that drive systemic change and completely eradicate one reason for failure. This is an actual quote. Don't just make the hamster run faster, and kind of exemplifies something we look at while working on the long-term action items. So long-term action items are a balance between, once again, 2 forces. One is delivering incremental improvement that is easier for our customers, for your customers, for the dependencies that we'll just see small changes little bit at a time. And the other side is driving systemic change, so innovation or reinvention, whatever we want to call it. Those are the cases where you go and build a completely new service and ask your customers to migrate to it. In real world, it's important to find a balance between them, because the second category is often going to have unrealistic ATAs. So who here has never worked in a company that has the old version of the system and then the new version of the system that is being built? It's unclear when it's going to go live, but nobody wants to touch the old version because there is the new one coming. Well, it's important to make sure that there is a plan also for addressing the old one if the launch of something new is too far out, as you ultimately want to prevent that failure from recurring in a reasonably short term. So thinking about the balance between delivering the perfect solution, so fully reinventing the thing, and the realistic ETAs or due dates that your customers are expecting from you is important. Once you have done this and you have a good plan, you'll start working on the actual implementation of such items. We try to do them with a few principles in mind. The first one is we fully understand that those plans might change. The initial phase is all hypothetical. You are trying to define solutions without testing them and to make an high-level plan. Once you go and implement those, you might figure out that there is a slightly better way to do it, or you might figure out that your initial plan wasn't really going to work. We are really happy being flexible about the plans, and we are happy making changes as appropriate as new information becomes available. While doing this, it's critical to defend the ATAs. So it's not easy, but any change you make in the plan should be done with ETAs, so the delivery time in mind. Making small adjustments, it's fine. Nobody's going to complain if you push it out by a few days on a multi-month commitment, but you cannot just push out an item that was due in 1 month over a few years. So thinking how plans can change as long as you stick more or less to the initial plan. And the third one, if you notice, we talked about a few closed loops. So we mitigate an event, but then we check with customers that they really see this mitigation. And once again, it's here. So I called it hypothetical. So while you were working on defining the plan. You were just working on the best knowledge. And then you went implementing, writing code, changing runbooks, changing processes. And at that point, you are confident that your plan is going to work. We don't really consider ourselves done until we have validated that the fixes worked. So we'll run what we call game days. We will just try and trigger the same, try and replicate the triggers to make sure that whatever happened the first time that they verified is not going to rehappen. So we only consider the implementation done once we have tested it. Might be obvious, but I think it's quite important as part of the mindset to think that we are only done after we have tested and validated that all the assumptions made to that point were accurate.
So the third phase in doing this is that we've talked about within a smallish team that owns a particular product, writing an RCA or writing a COE as we would call it, and working through action items. But what we want to do is make sure that we don't waste these learnings and make sure that we're using them across AWS. We don't want 10 more teams to discover these learnings later themselves. And so the goal here is to go to the next level and try to scale these learnings across the org. And so some of you may have heard AWS runs this AWS-wide ops meeting every Wednesday morning for 2 hours. We have the best part of 1,000 people at that meeting, which might sound strange, but it is a super valuable meeting as well as being a super expensive meeting. Personally, it might sound a little weird. I don't want to say that I look forward to incidents, but weirdly I kind of do, because I learn more about AWS from these incidents and from paying attention during these, and there are more opportunities to improve AWS during these incidents than at any other time. So it is kind of a weird situation. But so you can picture a room with a lot of people from AWS and senior people from AWS. So if you looked at the keynote on Monday night, Peter DeSantis, Dave Brown, they attend this meeting and they weigh in this meeting. And so what we're looking to do, we will typically take 2 or 3 COEs from across the org, interesting ones that everyone can learn from. We will review them in detail, and you'll have principal engineers, distinguished engineers going, you know what, we've seen this problem a couple of times before. A really good solution we did over in this service was this. And so you get a level of feedback that you wouldn't normally on your COE just from within your team. But equally, we have a lot of senior engineers taking in what's happened here, thinking about it, and it's kind of like getting stored up in their institutional knowledge so that when they're designing their next service, or for that matter, as they're operating their current service, they're aware of this problem and learning the lessons. Again, providing a safe space is really important here. We've now got a lot of really senior people and potentially like quite a junior person presenting the COE. It's actually quite an opportunity for the junior person, the way we do it. Like we make it a safe space. We are kind to the engineer doing it, and that is really important, because if we don't, it's just going to be very difficult to get the right learnings out of it if people kind of clam up. And so this is all about, this meeting is all about what can we learn from this. So in what ways are we actually scaling our learnings? The first one that I've talked about already really is kind of educating people, and we invest this 2 hours a week of a lot of people's time in order that we are building institutional knowledge, learning from these failures. Typically coming out of those meetings, if we conclude not only has this team had this problem, but actually there's a lot of teams with this problem, we may have to run a program across AWS and say, okay, we're all going to make changes to fix this problem, to upgrade that library or to change that retry behavior or whatever. This is kind of an expensive process, so we don't love doing it if we can avoid it, but actually cutting tickets to the 500 teams that need to change and having a program manager actually make sure that it happens over 3 months, it is very effective. But like I say, we don't love it because it is kind of expensive. A lot of teams end up with doing work. What we prefer to do is to go after centralized change. So the stars of this meeting are the people who own builder tools, the load balancing platform, the DNS platform, a few others like that who everyone else is depending on, because they are able quite often to make a change that won't be a breaking change for people, but will seriously change how this works out for everybody. And so ideally we look out for those really high leverage points to make changes. Like, for example, we will often make a change in one piece of code which everybody is going to consume through their pipelines shortly anyway. I mentioned also just about building culture and building institutional knowledge across the organization. This is just some examples of tenets. We've started to actually codify tenets, but I think we were informally, we had all built them in our heads over the years from all of these conversations. So like one that is particularly sacred within AWS might or might not be right for your business, but we want everybody across AWS to know failure must not impact multiple regions. This is a very important tenet for us. And this meeting is where that information gets out. So we've actually started to codify tenets. And the point is that we all agree on this. We don't debate this during the meeting because at this point we know. We will also aim to, one of the other tenets we have is that you should always detect failures before your customers do. And so there's no debate about that on Wednesday morning. If you want to get in trouble in Wednesday morning and get reactions from people, you should debate that. So that is a well-known tenet that we all accept. And before you're going into the meeting, you're already writing in your COE, yes, there's a problem here. Customers told us about this, if that's what happened.
And here we have an example about automating scale. So Gavin talked about distributed change in the internal view, but we also have this tool that is sort of our external interpretation of the same principle. So Trusted Advisor, you surely have heard about it. Trusted Advisor, what really does is looking in your accounts for anti-patterns or for things that we believe might be wrong. There are two categories that are relevant here. One is the red category called action recommended and gives you an idea of when we really think you need to act. So think about a root account without multi-factor. That it's extremely likely that you don't really want it to be that way. So that's a red check. We also have an intermediate category that is action recommended or review recommended. So we might notice that there is a single AZ RDS database, and we might want to flag it to make sure that you are aware and take an actual look in that resource to see if it's single AZ as it has to be or if there was a configuration mistake. And we consistently update those checks as we become aware of anti-patterns or risks so that customers can just consume our recommendations, sometimes even in a programmatic way. Looking about invention, so the third case I talked about earlier, when you just go and build something from scratch. Well, we have quite an experience here. DNS, as everyone knows, are quite a complex thing. We ran a few versions of our own control and data plane, and at some point we just decided to summarize those learnings into the service that became Amazon Route 53, and that today we use internally pretty much everywhere, and customers, as you are aware, use in their own use cases. Another similar one is the load balancing platform. We went through iterations of them and ended up summarizing all of those learnings and years of operating quite a large-scale load balancing infrastructure into the products that you know, so application and network load balancer. A third one, who has never dealt with the complexity of TLS certificate rotations at scale? You might have a calendar reminder once a year that tells you to switch that certificate. You might be running a program across the entire company where there is a dedicated PM tracking in a spreadsheet that everyone has rotated certificates. We had that as well. We evolved through an internal version of what then became AWS Certificate Manager, but AWS Certificate Manager was really our final iteration where we built a service that is a single pane of glass that allows you to track and check and rotate configure certificates across the entire organization.
So one of the other ones close to my space is a tool called Zonal Shift. When I joined AWS in 2011, we had internal tools for shifting away from an AZ. And through a set of COEs and a set of events that we analyzed, we started to realize that there were a couple of gaps in it that it had a couple of problems that weren't ideal and we wanted to fix, but there were a couple of gaps as well. It didn't cover all of the customers that or all of the services that we wanted to be able to quickly shift away from a zone. We realized we really needed to improve it, but also that we were starting to talk to customers and they were like, how do we shift away from a zone? We're not really sure how to do that, or it's very expensive for us to build that ourselves. So that is really how those learnings are what went into building zonal shift. Another one that we saw a lot was we saw a pattern over a set of events in which we would see retry storms. And people went away and thought about it a good deal and actually went and said, okay, there are real improvements we can make in our retry logic and we can build that into our SDKs. We build it into our SDKs. Over a couple of years, everybody consumes those SDKs. We will radically improve these events. And again, it's having that high-level ops meeting with everybody looking at a set of events and kind of really thinking deeply about what's happening. Quick, in case you haven't seen it before, zonal shift is this tool. So we have, I'm just showing a picture here of very simple load balancer NLB setup where we have traffic going to 3 zones, maybe there's database behind, and let's suppose some issue happens in AZ3. So zonal shift with a single API call, there's no charge for this incidentally, it is a freely available tool with all ALBs and NLBs, and it just allows you to steer traffic away and take the load in AZ1 and 2 instead. And that lasts for up to 3 days. Usually you'd use it for a few hours in order to investigate. Maybe you were deploying in that zone, maybe there is an incident in that zone, but it allows all customers to do that. And meanwhile, we are actually using this extensively internally as well. It has largely replaced our use of the old tools. I talked before also about this SDK retry story, and I'm going to give you some humble pie here. When I joined Amazon, I hadn't really thought about the concept of retry in code much, or really handled errors very well personally as a coder. Sorry. So the first code that I wrote tried to call that API once, and we ran it obviously 10,000 times, and it succeeded about 99.9% of the time, and then the other ones were like annoying failures that cut tickets and stuff. And, okay, yes, I needed to write some retry logic. Probably the first time I do it, I don't remember exactly, it was like immediate retry. So this is not a recommended pattern, but yes, I immediately retried on failure. So there's this bang, 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 we're hammering on the service. Now, if you imagine that my code is running across 10,000 clients and this happens, that's not pleasant. So the next iteration of not great but better is, well, we'll add a sleep in between them, right? Okay, so bang, 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 bang. Okay, better. But the problem with this is that if you think about over a series of 5 or 10 seconds, more and more clients going into this retry mode, the actual load on the service that's potentially having the problem here is going up exponentially. This is not good. This is not going to help. And so I think this is probably fairly common knowledge across the industry, but there is this trick called exponential backoff, where you retry after 1 second, then retry after 2 seconds, then 4 seconds, then 8 seconds. You're slowing yourself down so that the aggregate over the 1,000 clients isn't exponential increase of load. However, we're not really even, as we watched more and more events, that wasn't good enough even. We were noticing weird things like the clients all sync up together. From the moment of the failure, 1 second later, everybody retry, 2 seconds later, everybody retry, 4 seconds later, everybody retry. And so we started adding jitter into that as well, just to kind of smear things out and be as gentle as we could. And even that kind of, yeah, okay, that's better, but it's not great. And it turns out that retrying when the retries are not helping is just not a good idea. You don't want to take a struggling service and add to its load unnecessarily or in a way that isn't going to help. And so where we are at this point, and this is really developed over our COE process, over us looking at these events, is this adaptive retry. So the idea of adaptive retry is to say we keep a budget for ourselves of how many retries we are allowed to make. And it's a pool that we're refilling only when the retries are successful. If the retry fails, we don't replenish the pool. And so if retries are not succeeding, we basically close out our retry window and just stop doing it. We'll keep sending the standard load, but it basically stops you from ballooning the load due to a service that's failing and allows that service to recover much more easily. If you're more interested in this topic, it is a very deep topic and I've tried to do it very quickly. Mark Brooker has a talk at reInvent this time. I can't honestly remember which day it is, so it may be still to run. But it is about this whole topic. And we have now built this into the AWS SDK, so if you're consuming that, you're already being more gentle to us. Thank you very much. Please do upgrade your SDKs and turn on adaptive retry.
So there are a few things that we want you to leave this room with today.
Yeah, so our key takeaways. The first one, looking back to the tech call, is we have an org-wide kind of agreement that engaging is good. Getting people onto the call quickly is fine. And leaders, VPs, are fine with being paged. And if you are a leader in your organization, being willing to be paged and never jumping onto the call at 2 a.m. when annoyed and go, why did you page me? Thank people for paging you because you want to help. And that has a really profound impact on time to recovery, that people are not punished, are in fact encouraged to engage extra people to help.
The second one is we recommend to communicate really fast. As soon as you are aware and confident that something is going on, just try to get a notification out to your customers. You're going to have time later to iterate and provide more details, provide more depth, but try to get the first notification out as soon as you're confident it's time to do it.
The other one I mentioned was that engineers are fascinated by root cause and will really want to do it. You have to be disciplined on these calls and push, no, we will mitigate first. We will learn the root cause later. It might slow us down getting the root cause, but mitigation is key.
The next one is about learning things only once. So a team is going to do something wrong and learn about it, but the biggest mistake you might make is to only leave that learning in the single team. Scaling learnings across the organization so that even teams that are not involved into the event learn how to prevent that type of event is absolutely critical and is going to really improve your life.
Whoop. The other thing that we talked about was reflecting and reviewing these events with empathy. And there's two sides to this. One of them is being reasonable and humane and nice to the people who were involved, who had to make difficult decisions, so that they feel comfortable. But also empathy in the sense of, I need to understand exactly why that decision was made. What information, like I'm looking back now with a lot of hindsight, but understanding why they made that decision at the time, what information did they have or what information did they not have that they made a particular decision, both at design time and during the event.
And the last one, spoiled by the broken clicker for records, is about sharing tenets. So make sure you define a small set of really crisp and concise rules and principles you want your entire organization to follow. They are useful for a couple of reasons. So the first one being that they are easy to remember. So your new engineers will learn them on day one and remember them forever. And the second one is that they help breaking ties and making sure that teams that are maybe not working really closely to each other really drive in the same direction. And when there is a doubt on what's the right thing to do, they can refer to the tenets that you have defined, and that helps setting the road for everyone. And so with this, thank you for being here. We are going to be available at the end of the room for any question you have. And if you are watching us from the other venue or in the future on demand, feel free to shoot us an email for any follow-up question or discussion you might want. Thank you.
Thank you very much.